in Pacific Grove, California. This video shows you how to take advantage of the tab called Outputs Flow Control and how to adjust the 4 to 20 milliamp span, the 0, and the span for the 0 to 5. Let's start with the 4 to 20 milliamp span. What I have here is a 2-channel digital voltmeter that's just running with a data acquisition system. So I'm going to select 4 to 20 milliamp full scale. It's going to inject that value known as digital span and digital 0. Digital span for the purpose of creating the condition that represents the full scale of the device. The digital span is 32,700, and our last data point is here, and 32,700 represents 60, and when we inject that number, we will be creating the full scale condition. So I'm going to click Start, and I'm going to move this over so you could see these two displays. Click Start. What it does is it injects the full scale value, and it tells me here to adjust the 4 to 20 milliamp span. I can push the up button to get this a little higher, a down button to make it a little lower. Each time you change it, it writes the new number that is correlated to the position of the potentiometer, if you will. And so I'm going to make this be between these two numbers they're talking about here. So 90, that's close enough. Now I'm going to adjust the 0 to 5. Now, even though both of them go, 3983 is what it's starting with. Now I'm going to create this little jump to 5, and I could play with this, but it's already nice. So the next one is the 4 milliamp 0. Click Start. It will inject that condition. It is 4 milliamps, and you can push the 764. That's close enough. And then we can do the same thing with the 0. So that allows you to make the device agree with your DVM. This is my DVM. This DVM could be 10 miles away, in which you'd be able to compensate for the voltage drop. So I'm going to bring this up just a little bit till it becomes positive. It's so darn low. That's 5 thousandths of a volt. Oh, okay, so we're good there. So we'll make it 10. So for the DAC value. Doesn't really matter the 0 so much. Now another thing we can do, I will show you this start substitution. Click over to drive, this button here, then slide this over, and as you move this, the voltage should agree here. This should say 20 milliamps, 2162, and if I were to go to the curve, so I'm going to move this down a little bit like this so I'll be able to grab it. I'm going to go to the curve, and I'm going to copy this number, 24, Control C, 24340 should say 30. And that's because when I go here, 30 is right here, and I could read the ticks and everything. So I'm going to copy that number, the number of ticks, Control C, that's what we're substituting. That's the digital raw value. And Control V into this place right there. And then go back to, don't really have to go back to there, but we want to see that the condition is correlated to, the flow should say 30.420. Flow reading as read by this device. Here's the reading the device. And the milliamps, the reference should be 12.112, and the voltage should be 2.535 within the uncertainty of the device. So that's how that works. And when you're done, click this button. these go back to 0, meaning they are being run in the real non-substitute mode. So that is an instruction for using this section and why you use and if you should ever need the zero and span. The good thing, you'll be able to know your current 0, current span, voltage 0, voltage span. These are the numbers you would be adjusting. And should you mess it up, you can always go back to configuration factory and you recover factory defaults.